Alright, so to start, I'm going to show you a few sample calculations, and then I'm going to do the rest by myself because they're going to take forever. But these sample calculations should just give you a feel for how to calculate relative absorbance, because we probably are going to need to do this on the lab exam. I feel like it would be a good question to just give us two data values and then ask us to calculate the percent relative absorbance from them as an example, just to see if we know the formula or not, which is going to be each individual absorbance value column over the highest in a said column. So by value column, it's going to just mean one of these guys, one of the little squares. So, and then the highest one. Okay, with that little definition, we're going to start with this first value column for olive green, which is chlorophyll B, and we are going to do the calculation by dividing this by the highest value in the given column out of all of them, only for this respective pigment. Each of them will be unique. For this one, the highest value in this column is going to be the 420 nanometers wavelength of light, the 0.109. So this is what we would be dividing all of them by instead for this guy. So it's going to be different for them all. Okay, we're going to write that out. So for olive green value column 1, I have 0.0, focus, or I'll freak out. Thank you. 0.042 nanometers. We're going to divide that. Alright, so as you can see, I have now divided the given value for the respective value column by the highest in the total column, which was 0.079, and I multiplied that by 100, and we got 53% is our percent relative absorbance for 400 wavelengths of 400 nanometers of the light. So yeah, that's a wavelength. So now we're going to take this guy. This is the most tedious process on earth. We're going to take 53% and we're going to plop it right here. That's a 3. Right here. We're going to put it right here. Okay, and now I'm going to do that for every single one. And then I'm going to make a graph from it. So, just for another example, I'll do one more. Actually, I'll do two more. Just why not? 0.0. I could probably just erase that and rewrite it, but I don't really feel like it. These are nanometers, by the way. Divided by 0.079, our highest value from that column. We're going to divide that. We're going to multiply that by 100, and that's our percentage. One more thing for those wondering who may be following along or just curious about this. Yes, these do have decimals after them when I do it. It's a bigger value than just these two numbers. So you can see for this actually ended up with like 70.88607 something. He doesn't care about sig figs. So if you see me just put, like, if you do this and with my data values and you get as practice, just to make sure you're getting the right values or something, and you're getting one number off or something, it's just because I'm rounding them because it bothers me, and we don't need to have sig figs, but I prefer to keep sig figs because this is 2 decimals, so I'm doing 2 significant figures, not 2 decimals, 2 sig fig, 2 sig fig. I just like to do that, so I'm probably going to round this to 71%. Okay, so now we are going to be about at this little value right here. So let's see what we get. Yep, it's 100% because that's the highest data value in this specific column. So if you get that, normal, good. I know this is something kind of random to add, but I do sometimes double check everything I do and question myself to a very big amount. So yeah, if you get 100% at one point, that's normal. It should be with your highest value. Okay, so that aside, I hope this has been a decently clear understanding just for calculating these guys. I'm going to do this whole graph, and then, or this whole chart rather, and then I'm going to make the graph. So thank you.